Grade 11 Mixed, Chapter 2 review. We're doing question 3A. What page is this? 120. Okay. So first question says 7x squared minus 14x. Okay. Determine the missing factor. So they've already given us part of the answer. So what we're going to do instead is we're going to assume we don't have any of the answer. And they just want us to factor. Okay. Whenever you're factoring, always look for the GCF first. Have they taught you this? The greatest common factor. Okay. So what I need to find first, I need to find a common factor between the two coefficients. So those are the two numbers. Can you think of a common factor between those two numbers? 7. Okay. So 7 works perfect. So I'm going to be dividing each of these by at least 7. Okay. Now on top of that, is there in the variables? Is there a variable I can divide both of those by? X. Just x. Now, do you know why it's just x and not x to the power of 2 or anything like that?
Because then you can use that one.
Yeah. So we always take, when we're finding a common factor for variables, we always take the variable with the lowest exponent. So the lowest exponent was 1 here, so we divide each by x to the factor of 1. Now, those numbers don't disappear. They actually go to the outside of brackets now. So we have 7x, and then in brackets, we divide the terms above, and whatever's left we put in the brackets. So 7 divided by 7 would just be 1. And x squared divided by x, do you know what that would be? Just x. Subtract. 14 divided by 7?
2.
And x divided by x? Well, not 0, it's 1, but we don't have to write the 1 in, because 2 times 1 is still 2. Okay? So what actually happens is we get 2 times 1, but because it won't change the number, we could just write 2. Does that make sense? Yeah. They cancel each other out. So that's it. Our answer is 7x times x minus 2. Number 5 tells us the area of a rectangle. Okay? So let's actually get a rectangle out here. So we have some rectangle, and we know the area of this shape is equal to 6x squared minus 8. Is that right? Okay. Well, what else we know is we know area of a rectangle is our width and our length, right? So area is equal to length times width. We also know the area is this, whatever this amount is. So essentially, we need to break it into two separate numbers, two factors, things that are multiplied by each other to get this area. So in order to find the area, the length and the width, we're going to factor this term. Okay. So when I go to factor that, what can I take out of this?
6.
Can I take a 6 out of both terms?
2.
All right. We can do 2 and 2. So we end up with 2 times 3x squared minus 4. Does that make sense to you? So essentially, we're not sure which is which, but this is 2 times that amount. So we could say that the length is 2 and the width is 3x squared minus 4. Or maybe it's the other way around. We're not quite sure which is which. So essentially, this width could be 3x squared minus 4. And our length, we'll say, is 2 units. So because we factor, we know that this times that is going to give us that. So these could represent the lengths and the widths of this rectangle. Does that make sense? Question 6. Okay. They've asked us to give 3 examples of polynomials that have a greatest common factor of 7x. Okay? So I'm going to make one up quickly. And then I'm going to show you a trick to making these possible. Okay? So I'll make one here. Let's say we had 21x cubed minus 14x squared plus 28. Okay? This is a polynomial, and don't forget that. The common factor that I can take out of all of these terms, 7x is exactly what they're looking for. So the factored form of this would be 7x, 3x squared minus 2x plus 4 would be the factored form. Now, does that make sense how I got that?
Yeah.
Okay. Now, a way to create a polynomial like this, so I factored one, that's nice, but a way to create one, here's or this is what we could do. What you could do is start by expanding instead. So we start with 7x on the outside, and then we're just going to put in random terms on the inside. In fact, I'll make a 4-term polynomial, okay? We're just going to put these numbers. 5 plus 6x minus 9x plus 2, okay? Oh, actually, this will simplify to a binomial, so what I'll do is I'll make this a little x power of 2, 1, and we'll make this an x squared, just so there's 4 terms, okay? Now, to actually create the polynomial with it not being in factored form, I'm going to distribute the 7x into every term here, okay? And if you look, 7 times 5 is 35. X times x squared, x3, yeah, x cubed, or x to the power 3. All right, next one, 7 times 6 gives us 42. X times x to the power 3 gives us x to the power of 4, yeah. 7 times 9, yeah, negative 63, because it's a minus sign. And x times x, yeah. And finally, 7 times 2, 14x. And there you have it. We now have a polynomial where 7x is a common factor. I just created it like that. So you can do it anyway. You could do one with the binomial, a trinomial has 3, 4, 5. They just want you to make 3. So make up 3 equations that have 7x as a polynomial. Okay, so now we need to find the factors of this, okay? Now, there's 2 ways of doing this. First, we're going to talk about our theoretical model. And what that means is they usually represent trinomial like this, with a being the first coefficient, b being the second coefficient, and c being the constant term. So I'm going to recognize in the trinomial I have here which is which. So my constant term, or my c, is 14, my b is 9, and my a would be what number? You know? Yeah, it's just a 1. Okay. Now, when a is 1, there's a shortcut to this. And the shortcut's like this. You need 2 terms when a is 1 that multiply to c and add to b. And that's how you'll find the second terms of your factors. So essentially, here's your factored form. You're going to have 2 brackets, okay? And to find the second terms in both brackets, it's going to be these terms here that we just talked about, okay? They'll be the second terms. When a is 1, your first terms are always going to be x and x, or 1x and 1x, okay? Now I'm going to think of 2 terms that multiply to 14 but add to 9. Can you think of any? 7 and 2. Yeah, and they're both positive. So positive 7 times positive 2, positive 7 plus positive 2, both equal what we're looking for, which are 14 and 9. Okay? So this is really easy. We have 7 and 2 plus 7 plus 2. That's very simple. The downside of this is when a is a number other than 1, this shortcut does not work. Okay? So I'm going to do the same question. And there's a couple different ways we can do these things. I'm going to do this one a little different. Okay? I'm going to show you a way that works always, no matter whether a is 1 or another number. Okay? So let's say we have the exact same question. X squared plus 9x plus 14, right? This one, it looks a little more complicated, but once you get the hang of it, it always works, and it's a pretty fast way to factor. Okay, same idea, a, b, and c. Instead, what I do is I write my factors of a out. What are the factors of 1? 1 versus times 1. Then I write the factors of c, which are 1 and 14, and 2 and 7. now that I've written them out, I'm just going to make them columns, okay? These are the first terms. These are my second terms, okay? What I mean by my first terms and my second terms, I mean in my brackets, this column is going to represent the first terms. So because I only have one column, I know what my first terms are going to be. It has to be those two numbers. So 1x and 1x, which is also written how? Yeah. So exact same as above, right? Worked fine. Now, here's how I figure out my second terms, okay? And this will work even when a is a different number. I'm going to be multiplying the first column by one of these two columns, and their product has to add up to b, which is positive 9. Okay? So this is relatively straightforward with this. 1 times 1 and 1 times 14 would give us 1 and 14. Does that combination work? Add them, subtract them, does it work? No. And then if I go across, 1 times 14, 1 times 14, I still get the same two numbers. Does it work? No. So I know these are not the pair we're looking for. 1 by 2 and 1 by 7, we get 2 and 7. Do they work? Yes. So let's remember. We had 2 and 7. Okay. Now, because we are using 2 and 7, normally what happens like this. Here's the trick, because when we do it with a, you have to remember this trick. Because I multiplied 1 by 2, the 1 and the 2 have to go in separate columns. So the 1 would be here, and the plus 2 would be here. But because both the first terms are the same, it doesn't make a difference. That's why I didn't make a difference in the other shortcut. So our two terms are going to be positive 2, which we used here, and positive 7, which we used here. So we have plus 2 plus 7. I know this seemed like a lot more work, but if a is another number, we're going to have to use this style. Okay? Okay. So we've got question D. It looks a bit funny to what we're used to working with. That's because we're used to working with, and we'll write it here.
Sorry, is it x plus 5?
The other one?
Yeah. X minus 5, because I wasn't paying attention to that.
Yeah, they're half. Yeah. What's important here is I want you to remember x squared plus x plus, and we deal with an a, b, c. If you look at the order, my x squared is the first term, x to the power of 1 is the other, and then it's the constant. I always order them by exponent, whichever has the highest exponent. So I'm going to rearrange this. I would get x squared minus 8x plus 15. Does this make sense?
Yeah.
Okay. So now I'm going to write the factors of my a. What are factors of a?
1 and 9.
Factors of 15?
1 and 15 and 3 and 5.
Great. We know that their product has to add up to b. What's b?
Negative 8.
Negative 8. Okay. Quickly go through these two columns here. 1 by 1 and 1 by 15. Any combination of those work? No. 1 by 3 and 1 by 5. 3 and 5. Any combination of those work? Kind of, right? Something's missing. Positive 3 and positive 5 don't work, right? I'm going to be multiplying these, 3 and 5. Now, what I can do to make them work is I'm just going to put negative signs on them. Okay? Which means these two columns, I'm going to put negative signs here. So I'm going to have negative numbers. Now I have to make sure it works. Does negative 3 times negative 5 equal positive 15? Then I can use these two terms, because they both multiply to that, and they're going to add to this. So now I'm going to get x, and well, technically it goes in opposites, but they're both 1, so no difference. Negative 3 and negative 5. Does that make sense?
Yeah.
Now, we're doing factoring still. Now, decomposition, what we're doing is we're taking the middle term and we're actually breaking it into two terms. And when breaking it into two terms, we're trying to get two terms where one of the terms will work with a factor of 6 and the other one will work with the factor of 1. Something we can take groups of factors out. So this is almost a trial and error. For instance, this is 1x. There are many options for 1x or x, right? So one option for x would be 2x minus 1. Okay, that can come out. We can do 3x minus 2. Sorry, x. Don't forget the x's there. Will equal that, right? We could do 4x minus 3x, 5x minus 4x, 6x minus 5x, right? These are all options here for decomposition. So what we're going to do is we're going to take numbers out. We're going to set up two that will work for this decomposition. So we'll work with, let's say, 2 and 1x. Okay? So we're going to get 6x squared plus 2x plus x minus 1. Okay? Now, when we take a look at this, what has to happen when we decompose them, the two brackets have to be the same when I take numbers out. So I have this and this right now. Okay? When I look quickly, I'm going to take a common factor out of here. 2x will work as something that comes out. And I'll be left with 3x plus 1, right? But in my other bracket, I'm left with x minus 1. Not something that'll work, because the whole point of this is to find a pair of brackets that are the same. Okay? So through decomposition, this didn't work as a trial and error method. Okay? So I got to go back to the drawing board here. I know those two didn't work. That was as far as I could go with it. Now I got to think of some other numbers that may work in here. Okay, another set we could work with are maybe 4 and 3. So where do you want the 4 and the 3? Do you want the 4 paired with this? Minus 3x minus 1? Do you want them paired up like that, or do you want to switch the order? With the 3 with the 6 and the 4 with the 1? Switch it? Sure. Minus 3x plus 4x. They both still work. When I put those together, we get positive x. Alright, and now let's take a common factor out. When I take a common factor out of 6x squared, so essentially what I'm doing is I'm setting up this, right? When I take a common factor out, I can take 3x out, and I'm left with what? 2x minus 1? Yeah. Can I take a common factor out of there? 2. I can take a 2 out of this? Can. Is this going to work? Are my brackets the same? No.
And I guess 3x minus 2x.
There's a pair that's going to work, probably. 3x minus 2x. Okay? So we got to do a lot of thinking ahead when we go to decompose, right? Plus and minus. Now, here's where we set them up. We could take what out of here? 3x, and we're left with 2x plus 1. And what do we do here? We're left with 2x minus 1. Did that work?
Yeah.
Did it? Are the brackets the exact same?
Yeah, because when you multiply negative by negative, it switches
The signs around. Okay. The only problem is this just says minus this bracket. Think of it like that. We're dealing with that first. So we're kind of stuck here. Okay. Now I'm going to show you a smarter way of going about decomposition, okay? So that was a trial and error way. This is a way that'll work, okay? So here's the smart way of decomposition. Instead of our trial and error method, which really didn't work out, right? We were trying way too many different methods. Here we've broken it down where we have our A, our B, and our C, okay? To figure out what two numbers we got to break these two into, it needs to be a pair that adds to B, which is this term here, and they need to multiply to our A term times our C term. So in other words, what that means for us here is we need two numbers. We'll put it on the side here. Something plus something equals positive 1. That's our B term, right? And we need something times something, same two pairs, that equal to 6 times negative 1, which is what? Negative 6. So they got to multiply the negative 6. So when we look through this, if we use from our pairings, if we use 3 and negative 2, so negative 2 and 3 and negative 2, we know that 3 plus negative 2, okay, and 3 times negative 2 is 6, okay. So now let's go into our decomposition method, which we did find through trial and error, but we were still having a little trouble setting it up, right? All right, so we're going to go set this up. Okay, so we've done our little decomposition here. We've broken the 1x into negative 2x plus 3x, which we said were their numbers here. And I've paired them with these numbers because when I find this is now factoring by grouping, I find a common factor here. I'm going to take 2x out, and I'll be left with 3x minus 1. And then here, there are no common factors, but I am left with 3x minus 1. Does this make sense? So now, factoring by grouping, I take 3x out of both of these. Do you remember this? Okay, so 3x minus 1. And then in the other bracket, what am I left with?
2x.
Plus, what number is technically here? 1. It's 2x plus 1. Okay, so decomposition, it can be done. All right, this is the proper way to do it. They got to add to the middle term, multiply to A times C. Okay, and then we got to pair them in here properly. Now, I may have paired them backwards the first time where we did 3x minus 2. And if you notice, the brackets were close, but the positive and the negative sign weren't the same.
Yeah.
We'd switch them up and try it the other way. It's going to work if they fulfill those factors. Now, the other way we could have done this, okay? The other way we could have done this is like we had said before, right? We had 6x squared minus x minus 1. Is that right? Factors of 6 are 1 and 6, 2 and 3. Factors of 1 are 1 and 1. Okay? We know the two terms need to add to negative 1. We set up our columns.
Wait, so it's positive, so 6x squared plus, is that?
Oh yeah, it does. It makes a big difference. It's plus 1? Yes, that's right. Just got to add plus 1. Okay? Now if you look at this, when we go into our factor form, we only have one set of second terms. We know they're going to work. We just got to figure out which pairing it'll work with. And from our question before, we can probably guess. Well, we'll go trial and error. 6 times 1 and 1 times 1 gives us 1 and 6. Is that going to work? No. And 6 times 1 and 1 times 1, is that going to work? 6 and 1?
No.
So we know our first set, our first column, no good. 2 times 1 and 3 times 1? 2 and 3, will that work? No, it won't work. No combination of 2 and 3 can get to positive 1.
Or if it was negative.
If 3 is negative. Oh, sorry. If 2 is negative, good call. If 2 is negative and 3 was positive, then we could get there, right? So we get negative 2 and positive 3. Now, here's the tough part. In order to make that negative 2, this one had to be a negative, right? And think about it. Negative 1 times positive 1 is negative 1. So, we're going to put in our terms. Our first term is 2x and 3x. Now here's where we do the opposite brackets. we had to multiply the 2 times negative 1, so the 2 and the negative 1 have to go in opposite brackets. 3 was times positive 1, so 3 and positive 1 go in opposite brackets. Okay, and if you notice, we end up at the same answer, 2 different ways of solving it. Okay, exact same answer, 2x plus 1 times 3x minus 1. All right, let's try another with decomposition here. All right, remember, I need 2 numbers that are going to add to what? Which is our positive 9. And the same 2 numbers are going to need to multiply to 12 times negative 30, which is going to be, I think it's 360. Yeah, negative 360. What happens here is, with decomposition, like I said before, you can get a lot of terms now. Wow, 360, there are a lot of factors of 360, right? So I can start writing them out here on the side. 1 and 360 is a pair. 2 and 180. 3 and 120. 4 and 90. 5 and 72. Right? Yeah. 6 and 60. 7? No. 8? 8, yeah. 8 and... What's another pair? 8 goes in how many times? 8 goes in 45 times, is that right? Yeah. 9 go in? Yeah, that's right. 9 and 40? Okay. 10 and 36? Oh gosh. 11? No. 12? Yeah. 12 and 30, right? Yeah. 12 and 30. 13? No. 14? Does 15 go in? Yeah. 24. 15? 24? Okay, so after looking at all these pairings, are there any more? 16? No, 17. 20 would go in. How many times does 20 go in? 18. 18. All right, that's about right, right? Because now we switched over. 15, 16, 17, 18, 19, 20. Okay, so I think we've got all our pairs. So through decomposition, the only downside is, 1, 2, 3. I got a lot of options to go through to get the positive 9, right? I can tell you quickly by looking at this which one's going to be. Yeah. But it took us a while to do that. Where in the other one, we can kind of just write out the simpler factors of the two. We'd only be doing factors of 12 and 30, stuff we know off the top of our head. All right, so we need 15 and 24. And how do we need to do it? We're going to need 24 to be, which one of these is going to have to be negative? Because 24 plus 15 is a 9. Yeah, that's right. So now we have 24 minus 15. Okay. So now when we go to break this up, we have 12x squared. When we break the 9x into 2, what do you think we're going to put with which? Which one will 24x and negative 15, because we have to do the negative 30 as our other pair. Which do you think we should go with which?
Negative 15 should go with 12.
You think so? Okay. Negative 15, let's try it, x. And then 24 here?
Yeah.
That's 24. Okay, let's try it out. What are a factor of 12 and 15? Oh, actually, 3x. We get 4x minus 5. Plus, what would be factors of 24x and 30?
6.
6. That gives us 4x and 5. Hey, it works. Perfect. Nice. So, when we go to put these out, what do we get as our first bracket? 4x minus 5 and 3x plus 6. Does that make sense? Great. Do you want me to do it the other way quickly? Just so we have both methods. 12x squared plus 9x minus 30. Okay, we need factors of 12. 1, 12, 2, 6, 3, 4. There's a bunch. And 30's got a bunch too. 1, 30, 2, 15, 4, no, 5 and 6. So we have quite a few to try out, which is exactly what happened with the other one, right? Because we have 3 sets of first terms to go through and 4 sets of second. This is going to take a while too. Okay? Quickly by trial and error. I can probably tell you that 1 and 30 and 12 and 30, no, we're going to have huge numbers here, right? And even when we cross, we'll get 12 and 30, too much, right? Won't work. 1 and 2, 12 and 15, going to have huge numbers again. We'll get 1 and something. So we know those are illogical. But how about 2 and 12 and 1 and 15? Will that work? That'll give us 24 and 15. And which would have to be which? So, through this method, we ended up figuring out that 12 and 2 works, 1 and 15 works, right? That gives us 24, 15. Only thing is 15 has to be negative, so that we get to positive 9. Oopsie. And we put them in our brackets. We got 1 and 15 have to go in opposite brackets because we multiplied them, and 12 and 2. And look at that, we got now 2 different answers that work. Technically, we would have, if we kept going and we got to this column and this column, we would have noticed those 2 also work, which was our answer from before. And this one works too, because when we multiply across, we get 15, 24, yeah, negative 30. That set works also. Pretty neat, eh? Found 2 different answers. So what was good about the other method is we actually ended up with 2 options. So more options of getting there. Here we were kind of trial and error.